Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. As we continue with our reactions in organic chemistry, the next part that we are looking at is the elimination reaction. And from the word, you can see that we are taking something out. What is to eliminate? If you are eliminating something, you are taking something out, So that is the elimination reaction. And the first one that we're going to start with is dehydrohalogenation. So you can see this word. When you see the word, it's actually divided into three parts. The D is the part that links you to elimination. See? And that's why when you say I'm dehydrated, meaning you lost water, you eliminated water from your system. So D means loss. That's the loss part. So we need to know what we are losing. And then hydro is the hydrogen. And then halogenation is the halogen, which is the X, and X, remember, can be F, Cl, Br, and I. Remember that. So dehydrohalogen, it's minus HX in a way, minus, meaning we are losing maybe a hydrogen iodide or HBr or HCl. We are losing it, minus. That's what it means. So now they are saying here, in this dehydrohalogenation, they are saying the elimination of hydrogen and halogen from a haloalkane. So it says reaction conditions. Whenever I want to bring note to you now, when you're talking about reaction conditions in elimination reactions, don't forget you need strong base, and that strong base, there are two common strong bases. It's sodium hydroxide and potassium hydroxide. They need to be strong, and then you need to dissolve them in pure ethanol, and then they strongly heated. Now this thing whereby sodium hydroxide or potassium hydroxide is dissolved, capital S, dissolved in pure ethanol, there is a special name that they give. They call it ethanolic sodium hydroxide. So you'll hear statements such as ethanolic sodium hydroxide or ethanolic potassium hydroxide, if I'm to write it by name. Ethanolic potassium hydroxide. Don't forget, whenever you see ethanolic potassium hydroxide, strong base, you must know it's elimination. It can be dehydrohalogenation or dehydration, whatever is long. It's a strong base, and then pure ethanol, or they mention that is ethanolic or pure ethanol. You must know that. And then in these reactions also there are minor products and major products formed. Let's look at the examples. If I'm doing bromoethane, this is a haloalkane. Bromoethane, how does it look like? Bromo, it looks like this. This is my H, this is my H, this is my H, and then I'll have my Br there. This is bromoethane. So now if I'm going to eliminate, remember I'm dehydrohalogenation, look at this, then I'm eliminating it. What are the reaction conditions? Number one, we said you can just write this, ethanolic, and then you say sodium hydroxide. It's known. Or you can do it like this. Or you can do that, sodium hydroxide, and then you also plus heat. Heat is important. Or sometimes they do it like this. They will say sodium hydroxide, and then they indicate that to show that there is heat, and then they say ethanol. Are you with me? These are very important reaction conditions. Now, when you get that, remember we are eliminating. What are you going to have? I'm going to take off this part. When I'm eliminating, I'm going to take, remember hydro is dehydrohalogenation. So you're taking a hydrogen and what? A halogen. So these two not from the same carbon. Don't be tempted to do this. No. You must take it from the two carbons, carbon 1 and carbon 2. One from the other carbon, the other one from the other carbon. Then you can see that when you take that, the moment you remove, a double bond is retained, so that you have that, you have that, you have that. You see, you are forming now an alkene, but plus what? HBr. HBr. That's why they call it hydrohalogen. So that is what you get. So it's plus that. Is it making sense? This is what you are actually eliminating. That's why they call it hydrohalogenation. So you took that. All right. But actually not that. Let me correct this. Remember, we added sodium hydroxide. Actually this sodium, correct that, it will be actually sodium bromide. It's a salt. Sorry about that. This is a salt, plus then this H and OH, it will become water. H, it's actually H2O, but you write it as HOH if you're dealing with the structural formula. Are you with me? So it's salt and water. It's not really dehydration, it's the dehydrohalogenation, where there is ethane and then there is the sodium bromide as part of sodium, and that because sodium will become sodium plus and OH minus. So this will take that and this will take that. Alright, let's try another one. Another one that we have is what? 1,2 dichloroethane. Look at this. 1,2 dichloroethane. How does it look? It looks like this. There is chloro. There is chloro. That's a 1,2 dichloroethane. So when you're eliminating in this part, the first part, remember we are saying you are eliminating this. It's plus, let's add it actually, plus sodium. Let me use potassium here. Actually, it's the better one is to add it. I think this is much proper. Plus, this will be proper actually. Plus potassium hydroxide, right? And then we can put the reaction condition here. I think that after that, what you are saying, it's ethanol, and then you add heat. That sign is to say, or you can write as heat, but that sign is to say heat. What do you get? Remember, the aim here is to remove a hydrogen halide. So the first one that is going to happen is, let me write this potassium hydroxide. It is like this. It's K. Let me write it the other way around. It's O, H, and K. That's the potassium hydroxide. So what is going to happen is these will attract it to come and take this, and also at the same time, because you mustn't take from the same carbon, in carbon 2 that is going to happen. Take it from carbon 2. So what are you going to have? You're going to have a C double bond that, and then it will have what? H. Here it will have what? Cl. Here it will have what? H. Here it will have what? H. Do you see what happens? I've taken the first one, plus potassium chloride, right? Plus water, HOH. Just wanted space there. Do you see what's happening there? That's what you had, plus water. Don't write H2O, they might penalize you there, as if it was the structural formula. You can write it like this. But you see that this is ethane, this is an alkene, which is 1-chloroethane plus potassium chloride, which is a salt, a halogen salt, or halide salt and water, but it doesn't end up here, this reaction. This reaction continues. You can actually do this, because if they say this was potassium hydroxide was in excess, you can actually continue and say it doesn't end. You continue and say extra potassium hydroxide, OH. If it was in excess, and then again you're saying here there is what? There is ethanol. Now we're in reaction number 2. Reaction number 2, now you take that, you write that again, and then what happens? There is another water coming out, and then in this case there is the potassium chloride there. You see? So what are you going to have? You are going to have a structure like this. It's now from double bond is triple bond. You've got hydrogen, C, triple bond, because we've taken that, and then C and hydrogen. This is now ethine. But is it the end? Plus what? Plus K, Cl plus O, H, H, which is water. Potassium chloride plus water. You see that? That is another part of a reaction where it was 1,2 dichloroethane. What about this one? 2-bromobutane. Let me do it here. You want to do a reaction of 2-bromobutane, and then you want to do elimination reaction. Remember, it's hydrohalogenation. So look at this. Let me draw this 2-bromobutane. It's 1, 2, 3, 4. So I can make it here to say, let's make it here. This is 2. Then the rest is hydrogens. So this is bromobutane, but it's simple 2-bromobutane. Be careful now. That's where we come with the major product and the minor product. We looked at it previously. When you do this, look at this. Now I say plus my sodium, for example, hydroxide, and then we say here you need ethanol, pure ethanol. You can even specify you need pure ethanol, and then you need to heat it. Now what are you going to get? Then I'm going to use the arrow going down. Sorry about that. This is the arrow that is going down, because I want you to see. If I take it here, you won't see what's happening. So let's look at this. What are we going to get? 2 products are going to be formed. I'm going to divide them. The first product is, look at it, I'm going to take this one, is the one that will be eliminated. And when it is eliminated, remember though, the Br goes there, the H goes there to form what? They will form water and the salt. So what am I going to have? Now when I'm taking them, there is a double bond on this carbon 1 and carbon 2. That's where the double bond is. So it is going to be C double bond C, because that's where I took out. See that? And then we're going to discuss that. And then on carbon 3, nothing. It maintained there, it maintained. Alright, don't forget, I can continue to say, it's fine to say plus sodium bromide, of course, plus water, H2O. This is your H2O. Okay, this is water. Now what is important is this part. Let's do the second structure. I can take it out from this one. Similarly, the Br goes there, but this is the hydrogen that is changing. So what is changing is just the hydrogen. So now in carbon 3 and carbon 4, so I took out from carbon 3 and 4. You see that? So that is carbon, carbon, double bond, carbon. That's where I took out. Whenever you're taking out, remember you introduce a what? A double bond. Think that is that. Now the question is, similarly you take that to say plus, of course, plus NaBr plus H2O. water. Now, what is important here is which one is the minor product and which one is the what is the major product. Now, sometimes they use the word byproduct. The minor product is called the byproduct. The major product is called the main product. So look at this. It comes back from that Markovnikov's law. Remember, when we were adding, we said the hydrogen was attracted to the carbon with the most number of hydrogens. So when we are taking out, the same principle also holds. The carbon which has the least number of hydrogens, you're going to take that hydrogen from it. Remember the law I said? To those who have more, more shall be given. And then to those who have less, even the little they have shall be taken away from them. So it's a Bible principle. It says if you have more, more shall be given to you. If you have less, the less that you have shall be taken away from you. So you look now at these hydrogens. Look at carbon number 1, carbon number 2, carbon number 3. From these, don't focus on this one. This is carbon number 2 is the one that is not supposed to be looked at. Why? Because it has got our Br. See that? It's our focus. But the hydrogens to focus on is that and that. Then we ask ourselves, between carbon number 1 and carbon number 3, which carbon has more hydrogens and which carbon is less hydrogens? Carbon number 1 has got 1, 2, 3, which is more hydrogens. Carbon number 3 has got 1, 2. And then we say that carbon number 3 has less hydrogens. So the less hydrogens or the little hydrogens it has, it shall be taken even more. To those who have less, less shall be taken from. Markovnikov will say the carbon with the least number of hydrogens, with the smallest number of hydrogens, that's where you must take the hydrogen. So here, the one that we did in blue, so we're supposed to be, this is the one we took here because we want to take from this carbon. It has got 2. So this then becomes the what? The major product. So you come here and say major product. I told you another word for major is called what? Main product. They can use the word main product. Major can be the word main. And then the other one, this one is a minor product. Now another word for minor product, they can use the word what? Byproduct. It's a byproduct. Sometimes they call it a side reaction. It's not desired. It's a side reaction. It's a byproduct. Can be very small, 5%, 10%. It's a side reaction. The major one, 90% and above, which is called the main product, the actual reaction that is desirable. So don't forget, let me do it again here quickly. If I give you a molecule like this, and then we put, for example, our Br there, and then not there, this one is not gonna work. Let's put it here. It's better with 4 because if it's not 4, it's gonna complicate. If I do this, like this, and then I say to you, if I'm eliminating, I want to take out HBr, where will the hydrogen be taken from as the major product? You look at carbon 1, carbon 2 and carbon 3. These are the focus. Look at this and look at this. Don't look at the carbon with the bromide, alright? It's not gonna work because you can't take already. You have taken the Br. So the question is, which will the Br go to? Will the Br take this one? Yes. This is the major. Why? Already it's got 1, 2 hydrogens, but this is here. It is the minor. Why? It's got 1, 2, 3 hydrogens. So remember that. So whenever you're forming the double bond will be formed there. Are you with me? That's where you're going to draw the structure with a double bond. So if you're looking at the structure of this, what would be the name of this structure? This is 1, 2, 3, 4. It's butanol. It's butene. But. 1 in. But 1 in, according to this. Are you with me? But 1 in. That's where. Okay, this is the minor product, but the major product is what? But 2 in. But 2 in as the major product. Okay, this is sodium bromide. Sodium bromide. What is this? This is the salt, and this is what? Water. Don't forget that. You form the salt and you form water, and they form the alkene, but 2 in. So guys, we've come to the end of our lesson. Join me now in the next lesson where we are looking still at elimination, but the next part now is dehydration, the removal of water, the elimination of water from an alcohol. Very important reaction that you need to know. We've come to the end of our lesson. Remember to subscribe and ensure the notification bell is turned on. Thank you.